I welcome you to this session on time and work. In this session, we will take a look at the concept of people working in alternate minutes, hours, or day. It could be either people or any other things. So, how do you tackle a situation if two people or more are working but in alternate minutes, hours, or alternate time cycles? Let us take an example of two people, A, who can complete a piece of work in 20 days, and B, who can complete a piece of work in 30 days. Let us take their example to understand how we can tackle this situation. Let us assume that A begins on the first day. In such cases, the first thing that you should understand is because they are working on alternate days, A working on the first day and B working on the second day, then A works on the third day, B on the fourth day, and so on. So, if they work in alternate days, it is ideal to calculate the work done in one cycle of 2 days. Work done by A on the first day and the work done by B on the second day is equal to the work done in any one cycle. So, the work done in one cycle is equal to 1 day's work by A plus 1 day's work by B. Let us calculate that. Work done per cycle, in this case, the work done by A on the first day is 1 by 20 plus the work done by B on the second day is 1 by 30. So we can calculate that work done in one cycle is equal to 3 plus 2 divided by 60, or work done in one cycle is equal to 1 by 12. On simplifying the above expression, we get 1 by 12, which means 1/12 of the work is done in one cycle of 2 days here. Now we are required to find in how much time will the total work get completed. If 1/12 of the work has been done in 1 day or one cycle of 2 days, if 1/12 of the work has been done in one cycle of 2 days, one work will require, by a direct variation rule, we will get 1 into 1 divided by 1 by 12, that is equal to 12 cycles. Here we have calculated in cycles, therefore the answer is in 12 cycles. Now each cycle is of 2 days and therefore the total number of days required will be 24 days. Let us look at one more question. A can do a piece of work in 30 days while B can do it in 40 days. In how many days can A and B both complete the work if it is known that A and B work on alternate days with A starting the work? Again, we have A who can complete the work in 30 days and B who can complete the same work in 40 days. Now, A begins on the first day. Therefore, the work done in one cycle, which must be equal to the work done by A on the first day and B on the second day. So, work done by A on the first day is 1 by 30 plus work done by B on the second day is 1 by 40. Total work done per cycle is equal to 4 plus 3 upon 120. We get this on simplifying the above expression. And work done per cycle is equal to 7 upon 1/20th fraction of the work. So, which implies that at the end of 2 days or at the end of every 2 days, starting the first day, 7 by 1/20th fraction of the work will be performed, or 7 by 1/20th part of the work will be performed. So, in two cycles, the amount of work performed will be 7 into 2 divided by 120, that is equal to 14 by 1/20th fraction of the work. In three cycles, we will have 7 into 3 divided by 120, that is equal to 21 by 1/20th of the work, and so on till 17th cycle. We can count this till 17th cycle, and at the end of 17th cycle, 7 into 17 divided by 120, that is equal to 119 upon 1/20th fraction of the work. After the 17th cycle, we cannot complete one more cycle because only 1 by 1/20th fraction of the work is left. What is the balance work? 1 minus 119 divided by 120, that is equal to 1 upon 1/20th fraction of the work is left. And obviously, how much work is completed in the entire cycle? 7 by 120. So it is but obvious that the next cycle, the 18th cycle, will not get complete. Therefore, we break counting in cycles here. We say A can do 1 by 30th of the work because at the end of 17th cycle, only 1 by 120th work is remaining. And who will work on the first day of the 18th cycle? It should be A. So A can do 1 by 30th fraction of the work on the first day of 18th cycle. And therefore, this is the work done by A in one day. What is the balance work left? 1 by 120th of the work is balance, which is less than 1 by 30. So how much time will A require to complete this balance work? Again, by direct variation rule, we have 1 by 120 into 1 divided by 130. That is equal to 1 by 4th of a day. So A requires only 1 by 4th of an additional day to complete the balance work which is left at the end of the 17th cycle. And how much work was left at the end of the 17th cycle? 1 by 120th fraction. So what is the time required? The total time required is equal to 17 cycles of 2 days each plus 1/4 of a day, and which is equal to 34 plus 1 by 4, that is 34.25 days. Let us solve the same question by an alternate approach. A can do a piece of work in 30 days while B can do it in 40 days. In how many days can A and B complete the work if it is known that A and B work on alternate days? So far we've solved assuming that the total work required is 1 unit. Now let us assume that the total work is LCM of 30 and 40 as we have seen in the second session. So total work is equal to 120 units. What is rate of A? Rate of A is 120 by 30, that is equal to 4 units per day. What is rate of B? 120 by 40, that is 3 units per day. Work done in one cycle is equal to 4 plus 3, that is equal to 7 units per cycle. And we can continue to count in cycles for 17 cycles. Work done at the end of 17 cycles is equal to 119 units. So what is the balance work? Balance work is 120 minus 119, that is 1 unit. And how much work can be done by A? Because after 17th cycle, A works on the first day of the 18th cycle. And when A works, A will complete 4 units of the work in one day. And what is the number of units of work required to be done? 1 units of work. So how much time is required? By direct variation rule, again we have 1 into 1 upon 4, that is 1/4 of a day. So what is the total time required? We've spent 17 cycles completely, that is 34 days. And we have spent 1/4 of an extra day, that is 34.25 days. Let us solve one more question. Two taps A and B can fill a tank in 20 and 30 minutes respectively. A third tap C can empty the tank in 40 minutes. If all the three taps are operated for 1 minute each alternately, after how much time will the tank get filled? So once again, we can assume the total work to be the LCM of the three times given, 20, 30 and 40. So LCM of 20, 30 and 40 is equal to 120 units. So we assume that the total work or the total units of water to be filled are 120 units. So what is the rate of filling of A? Rate of filling of A is 120 by 20. That is equal to 6 units per minute. Rate of filling of B is 120 by 30. That is 4 units per minute. Rate of filling or rate of emptying of C is equal to 120 by 40. That is equal to 3 units per minute. Which means that one cycle is of 3 minutes. In the first 2 minutes of every cycle, the two filler taps are in operation, and in the third minute the emptying tap is in operation. So the net rate is 6 plus 4 minus 3, that is equal to 7 units per cycle. This is the net rate of filling of the three taps. And what is the maximum fill in any one cycle? The maximum fill is the amount of water filled in the first 2 minutes of any cycle. and that is equal to 10 units every cycle. So the maximum work done in any one cycle or the maximum fill is equal to 10 units. Now, the idea here is if at the end of any cycle, the balance water required in the tank is less than or equal to 10 units, then those 10 units can be filled in the first 2 minutes of that cycle. And therefore, that cycle will not be required to be completed. So let us solve it. After which cycle will the balance work be less than 10 units or equal to 10 units? So let us start counting. If in one cycle 7 units of work is done, then in 15 cycles, the work done after 15 cycles is equal to 105 units. What is the balance work right now? The balance work is 15 units because 120 units of work is required to be done. So 15 units are balanced. It is still more than 10 units. So we count one more cycle. Work done after 16 cycles is equal to 7 into 16, that is 112 units. Now what is the balance work left? The balance work left or the balance water to be filled is 120 minus 112, that is 8 units. Obviously this is less than equal to 10 units. So we stop counting in cycles after the 16th cycle. In the 17th cycle, which tap will fill in the first minute? In the first minute of the 17th cycle, tap A is operational and will fill 6 units. And we know that the balance required at the end of 16th cycle is 8 units. So what is the balance left after the first minute of the 17th cycle? The balance left is 2 units. Now remember, the next minute tap A will be operational. That is, every second minute we have tap B which is operational. So who will complete these 2 units? Tap B will complete these 2 units. And what is the rate of work of B? The rate of work of B is 4 units per minute. So B will complete these 2 units in half a minute. 4 units for 1 minute, and therefore 2 units, B takes half a minute. So in the second minute of the 17th cycle, B will complete this work in actually 1/2 of a minute. So what is the total time required? 16 cycles have been completed. So 16 complete cycles of 3 minutes each, 48 minutes. In the 17th cycle, the first minute has been completed. A worked for 1 minute. And in the second minute, B worked only for half a minute. So 48 plus 1 minute worked by A and half a minute worked by B, a total of 49.5 minutes. So with this, we come to an end of this session. If you have any feedback or any query, please feel free to write to us at studentservices@pfindia.com. Thank you very much.